Hello and welcome to another episode of Earth911's Sustainability in Your Ear. This is the podcast conversation about accelerating the transition to a sustainable carbon neutral society. And I'm your host, Mitch Ratcliffe. Thank you so much for joining the conversation today. Electrification of the world's transportation depends heavily on the ability to build efficient, fast-charging electric vehicle batteries in massive quantities. But shortages of critical minerals, battery failures that have spurred EV recalls, and China's battery manufacturing dominance, to name just a few challenges, have raised the question about the viability of the United States' goal to reduce carbon emissions by 50% by 2030. And I think there are a lot of important questions to ask about those goals today. Can America build a battery? A Business Week cover story recently asked that question, and it is very much a valid concern. Can we build enough batteries? Not without substantial innovation in battery technology and manufacturing processes. And our guest today is Andrew Hsieh, founder and CEO of Emeryville, California-based Liminal, which specializes in EV battery data and analytics tools for battery manufacturers. Liminal aims to help battery makers make better batteries faster. Liminal has developed EcoStat, an AI-enabled ultrasound battery inspection system that manufacturers can use to assess the performance of every individual battery cell as it comes off the production line. The process takes seconds and prevents bad cells from being integrated into finished batteries. Andrew announced a $17.5 million investment in February, which Liminal will use to accelerate the development and deployment of its inspection tools. Liminal has also received a $2.5 million grant from the California Energy Commission to help integrate EcoStat into automated manufacturing facilities, or what we call gigafactories. When you inspect batteries, you have the data to identify the promising technologies and assess the investments needed to achieve the Made in America goals for EVs and batteries set by the Inflation Reduction Act. So let's find out what Liminal sees ahead. You can learn more about Liminal at liminalinsights.com. Liminal Insights is all one word, no space, no dash, liminalinsights.com. Welcome to the show, Andrew. How are you doing today?
Good. How are you, Mitch?
I'm doing well. Thanks for joining and talking about batteries. It's such an important topic. And I want to start off, you've said that the U.S. needs to expand battery production by 20% a year to meet our goals as a nation. Are we on track to achieve that kind of progress?
Yeah, I mean, certainly we're doing a lot better now than we were a few years ago. Lots of plans and funding commitments for new factories have been announced over the last couple of years, which is super exciting. But, one of the things that I think we also need to realize is there's commitments and then there's actual production of batteries. And right now, that's kind of where there's a big gap. Even with all these flashy numbers, multiple tens of billions of dollars being put in, I think it's also important for us to understand that it can take years to actually get those factories built and commissioned, and another couple of years to fully ramp them up. So I think, we are going to see the benefits of all those plans, hopefully in the next few years here.
Yeah, when you say next few years, by the mid-second part of the decade, the 2027, 28 timeframe, do you think?
Yeah, so factories that were announced, call it last year in 2022, I would expect them to start actually producing cells that are going into cars, middle to late next year, and then really getting up to full nameplate capacity in the 2025 to 2026 timeframe. But that's assuming, supply chains are smooth and everything goes to plan.
Well, we always hear that this conversation in the context of government policy, but business investment is where really the rubber meets the road, not to make a pun. But Atlas Public Policy reports that companies invested about $128 billion in U.S. battery projects last year, 2022. Are we going fast enough? Do we need to ramp up the investment?
Yeah. I mean, it's ultimately, it's interesting because last year when the market and economy was struggling, you actually did see some companies pause or pull back on their factory plans. So, the idea that it's government policy and support really helps and is catalytic, that's absolutely true. But ultimately it's a business decision, and I think we are going faster than we've ever gone before as an industry, which is exciting. I think we need do need to go faster, and especially in the context of electrification of vehicles and transportation and climate change. Absolutely, we need to go faster. But there's a bunch of headwinds there that we also need to address from a labor perspective. I mean, globally, there's a shortage of people who have the skills and the training to manufacture batteries. So a ton of effort needs to go into workforce development and training programs. Another challenge is, by building factories more quickly, that actually kind of goes against the need for safer, higher quality batteries, because it's so much of an art, not a science right now. And, we'll probably get into this eventually, but that's a lot of what we're trying to solve for. And then kind of the other headwind is the economics of battery production, and EV production is not great yet. And so we need to do a lot to solve that, in order for, coming back to that business decision, in order for that to be a no-brainer for companies. And that's another area that we're hoping to make an impact.
Well, the scope of the opportunity is really compelling. Next Move Strategy Consulting estimates that EV battery markets are going to grow from $61 billion last year to $212 billion in 2030. And a lot of these business decisions are predicated on, how much demand there is out there and where it is. Does the United States, is it going to struggle to keep up with its own domestic battery needs, or will we be selling batteries to the rest of the world at some point, do you think?
I mean, I think it would be a huge win if the U.S. were to become a net exporter when it comes to batteries. But the reality is, right now, I think the U.S. is going to have to work very hard to even keep up with domestic demand and kind of reach a net neutral, if you will. So, but one other thing to point out, though, is there's this other trend that's happening in EVs and battery manufacturing of localization. So right now, raw materials, minerals are mined in one continent, they're refined and processed on another. Cells are manufactured, let's call it in Asia or Europe, and then they come to the US. Really complicated supply chain and logistics. But what people are finding is that actually shipping cells and finished battery packs, that's really expensive, and can in many ways offset the cost of the energy or labor that you might need to pay in Europe or the US. And so again, there's this trend towards localizing or having battery factories be at a minimum within the same continent, and ideally potentially within a couple of hours of train ride away from the cars factories that they're going to go into. So it's possible that even if the U.S. can keep up with all the demand, that just, the business environment is such that, everyone is more or less, a net neutral in terms of import-export.
So that move to localization is really an important one to understand, because this regionalization and the addition of circularity in there with recycling materials is a very promising opportunity to lower our impact as well as to make this more affordable.
Absolutely.
Now, first, do we have enough domestic sources of lithium, cobalt, and other things critical minerals that we're going to need? Do you have a sense of whether we're making progress there?
Yeah, I think this is a huge topic in the battery industry. So, I mean, it depends on the mineral that you're talking about. I think people are really finding interesting sources for certain ones like lithium, and obviously there's a big push towards iron phosphate based batteries, which has a much broader supply. I think when you start talking about cobalt and nickel, it gets a bit more constrained. So there's a lot of companies that are trying to find sources that aren't in conflict zones. And also additionally, there's a big effort to figure out how do we extract and refine these minerals with minimal impacts to the earth and to the communities around those mining sites. Because there's a lot of negative impacts there as well. So I think there's a lot of work to do there still, but it is certainly an important piece of the puzzle. And I think recycling, as you were bringing it up, it is a big piece, but right now, even if we recycled 100% of everything we make now, it's
Okay.
a tiny fraction of what we need for full electrification in the next decade or so.
Well, so it doesn't sound like the prospects are good for full electrification by 2035. Is that fair?
Yeah. Um, I wish it were not true, but I think that's fair. I think we'll probably hit full electrification towards the end of that decade, so 2040 or so. But GM, they have just decided that they are going to. I mean, their stated plans, company wide, are to fully electrify their fleet by 2035, meaning all the cars they produce thereafter are fully electric. But they also just announced that they're continuing to, or even ramping up production of their big money makers, gasoline powered SUVs, to sort of stock up on some of that cash before they, go into a lower margin future. At least that's their perspective now. So I think, there's a lot that needs to be done to across the board to make the manufacturing and supply chain work, to make the economics work, so that we can really try to get to more electrification by the middle of next decade.
When you say a lot of things to be done, let's say Andrew was put in charge of solving this problem, and you had unlimited resources. What would you do? What would you suggest we think about investing more heavily in doing?
Yeah, that's a hard question. Potentially, thankfully, I'm not in charge of that decision. There's a lot
I'm
of
not
things.
holding you responsible either, so don't
Yeah,
worry.
yeah. I mean, there's a lot of things, right? I think we sort of touched on some of it. Is the raw materials? We
Okay.
need to figure out, how do we find and extract and utilize all of those that we need, and as minimally impacted, with as minimal impact as possible
Well, do we
on
need to
people and
create
the environment.
incentives for that? Could the government, for instance, put a program in place to drive this faster?
I think that assumes that we have the technology and we have the sites identified to do that. So I don't think that's the case yet.
All
I
right.
don't know, but I don't think so. The other place is I think in manufacturing, and this is a little bit selfish for me, but in battery cell manufacturing and battery pack manufacturing, there's a lot of innovation that can go into um, finding ways and implementing ways to make that ramp up faster. Right? I mentioned it takes 3 to 5 years to build, commission, ramp up, and get a new battery production facility up and running.
Mhm.
What if there were innovations and technologies that could make that go faster by a factor of 2 or 3? And not only does that mean you get the supply up faster, that also means that you're wasting less material and cost to get there. Um,
Well, let me ask this, because we're
yeah,
talking about production and you all work in quality control in production. Tell us how
mhm.
EcoStat works and the efficiencies that it does create in the battery manufacturing process.
Yeah. So just to back up a little bit, the way that batteries are inspected right now in manufacturing, they predominantly use things like cameras, or lasers, or voltage and current, like electrical methods. So one analogy that I like to use sometimes is, it's like you go to the doctor, and when you go in, they measure your blood pressure, your pulse, your temperature, really important vital signs to say, yes, you're a human that is alive. But, it misses a lot of things, right?
Sure.
Not very prognostic or diagnostic by themselves. And that's sort of the paradigm that exists in battery manufacturing right now. So production issues can take weeks or sometimes even months to detect, and there's a big gap, and that creates a big gap and a source of inefficiency, as well as allows for quality issues to be missed. And so, in broad strokes, EcoStat addresses that in 2 ways. One is our inspection technology is able to catch those issues at their source when they occur, giving really tight feedback on when issues occur, which means you can fix that, do something about that quickly. And then the other thing is because of the technology that we use for inspection, so it's an ultrasound based measurement, we can actually more directly detect things that current methods are not able to. So that additional insight leads to further improvements.
So these things might be either physical flaws or flaws in the flow of the current through the storage medium?
Yeah, more on the physical side. So ultrasound, what is sound? Sound is basically just a vibration of things physically. And so really what we're doing is sending little tiny pings of sound, ultrasound into a battery, listening to how that sound wave changes as it travels across. And that tells us a lot of information about the physical health and the quality of the battery cells. And it takes a matter of seconds. And so you can actually implement this measurement. And we have and are implementing this measurement in multiple places within battery cell production to give manufacturers feedback and insight about the quality of their cells and the quality of their process, basically in effect in real time compared to what they're able to do now.
Well, so this should, in theory, prevent the kinds of recalls of batteries that the Chevy Bolt experienced or that stopped the production of the Ford F-150 Lightning for a month. So essentially, we are getting better at making batteries safer faster. Is that the best way to kind of summarize where the industry is headed right now and what your focus is?
So I think what we noticed is a shift in the mindset and the awareness of the need for better technologies and solutions for quality and safety in EV batteries. It's a weird thing to say, but that is in large part thanks to the $2 billion recall that LG and GM had a few years ago. And obviously continues to be highlighted by the Ford shutdown, which, I think if you do the math, we did the math, and we think it's roughly $700 or $800 million just for a month of shutdown production at that factory. So I think there has definitely been a growing awareness across the industry that more needs to be done here, which is why we've been getting a lot more inbound interest. But I don't think yet we have the technologies and the solutions to get there. And that's really what we've been focused on at Liminal for the last few years is, what can we do? What new data, what new analytics, how can we leverage the power of data in manufacturing in order to really address these issues? That's really what we're trying to focus on because that's so important for electrification.
Well, that is a great place for us to take a quick break because we're going to turn to those questions next. We'll be right back. Hey, extended producer responsibility, change makers, let's unite. Meet me and the Earth911 team in Portland, Oregon this September at the 2023 U.S. Product Stewardship Forum, the nation's only conference dedicated to EPR legislation and best practices. The circular economy is being crafted today, brick by brick, with EPR legislation, and packaging recycling efforts are leading the way. 2022 saw unprecedented momentum, with 18 states considering over 60 EPR bills, and 6 became law. This year in Portland, you'll find exclusive insights from globally recognized EPR experts. The Product Stewardship Institute invites you, the movers who will shake their regional recycling and composting systems with new ideas. Network. Hone your EPR knowledge and form strategic alliances to drive the circular results this world needs. Now is the time for producer responsibility. So join us at the 2023 U.S. Product Stewardship Forum in Portland, Oregon. That happens from September 11th to 14th. Register today at productstewardship.us. Product stewardship is all one word, no space, no dash. Productstewardship.us. Be a part of the solution because stewardship starts with you. And we are back to continue the conversation about the pace of development in the EV battery and large-scale energy storage industry with Liminal founder and CEO Andrew Hsieh. So, Andrew, turning to the questions about how do we get to this level of efficiency, do you see something that's the equivalent to Moore's Law emerging in battery technology that describes an annual improvement in cost to storage capacity for EVs?
Yeah, so there's an interesting, I think this applies to manufacturing more broadly, but there's something called Wright's Law that sort of describes and forecasts how the cost of a thing that's made falls as a function of the total number of that thing having been made. I think people have tried to apply that concept to batteries in particular. 10-ish years ago, lithium-ion batteries, I'll say, were roughly $1,000 per kilowatt hour, and then over the past decade, they've dropped to, let's call it $100 per kilowatt hour. So huge drop. And so it's an interesting framework to use to sort of project what are good targets to aim for and what might be realistic to expect. But I think in the same way that with Moore's law, it doesn't actually describe how you get there.
Right.
And so in the past, how did we get here? I mean, a lot of it was really interesting and important material science, but also more due to just pure economies of scale with supply chains, right? So, just making more cells, sourcing more materials, that gets more and more efficiencies because of just the scale that you're building at. But I would argue, and other people have argued that, we've sort of hit the floor in pure economies of scale, especially as a function of materials cost, right? Like we're seeing fluctuations in the price of lithium-ion batteries as a function of the spot price of the minerals that go in there. So then that gets us thinking, okay, going forward, how do we stay on this, Wright's law curve for batteries? We need other innovations that look at, well, hey, there's all these process inefficiencies because we've done the best we can in optimizing our process. There's still this like 10 to 15% inefficiency on cost, but we just don't know how to squeeze it out because we don't have the insights to do that. That's really where we're trying to focus on is squeezing out those other process-oriented, reliability-oriented, quality-oriented costs.
So even though we're reaching the floor on available resources, let's put it that way, the physics of those resources, of using those resources, can still be optimized.
Absolutely. Yeah, the physics of utilizing them and the physics of making them.
Mm-hmm. So is it simply a matter of building more manufacturing facilities, or are there efficiencies that we can really count on to lower the cost in materials refinement, battery architecture, and storage media generally?
So again, I'll go back to the speed of what it takes to scale up a new battery factory. So, if I do a production run and it takes me a few months to really get the signal that I need to understand, yes, these processes were the right parameters or whatever, and then I iterate and then I do that again, if I'm and this actually happens in the first few months of production, people can be scrapping, 60, 70, 80% of the cells that they make. And that can go on for a year, more than that. That's a ton of waste. And so if we can give our customers faster feedback on quality during commissioning, we can bring that yield ramp curve up faster, which means that scrap amount goes down much faster, which means there's less waste and less cost.
Well, so now EcoStack can look at all sorts of different battery technologies. Which ones, other than lithium-ion technology that we're currently using most of the time, do you think are most promising?
Yeah, so I would segment it by application. So if we're talking just EVs, I think, there's really interesting stuff going on with lithium metal batteries. Really taking that next step into high energy density, high capacity batteries. There's a lot of technical issues that need to be solved there, but if we can solve them, I think that takes us a huge way forward. There's a lot of interesting stuff going on the silicon side as well. But for me, luckily, sitting as the CEO of Liminal, we are agnostic to a lot of that. So it's okay. We don't have a horse in the race per se.
Right.
But as far as EVs go, yeah, silicon containing and lithium metal batteries are super interesting. If you start looking at grid batteries or stationary storage batteries, there's a ton of really interesting stuff going on for shorter durations with like sodium ion batteries, and then for longer durations with more interesting things like direct metal formation or thermal batteries that I think are really interesting.
So I've read that you're bullish on sodium battery technologies, and I noticed that sodium ion cathodes degrade a lot faster, so we would have to recycle those a lot more frequently. Do we have the technology to do that so that, for instance, if we build a big grid storage facility, that we'll be able to swap the batteries out without always having to go back and extract new resources?
I won't pretend to be an expert in this area. So I think there's a lot of great work happening on the recycling side. I think it's safe to say that most of that is focused on lithium ion or lithium ion adjacent chemistries and materials. But as sodium ion does get more widely adopted for various applications, I think you'll start to see more people focus on commercializing sodium ion battery recycling technologies. I will say, I think there are some people who are trying to commercialize it for electric vehicles as well. So we'll see. It's in a good way. It's the Wild West out there. There's a lot of exciting innovation happening in batteries.
So as you think about the mix of battery technologies that we'll be using over the course of the next decade, how do you think it's going to fall out? Will lithium continue to dominate, or will we see a much more heterogeneous mix?
Yeah, I think it's going to be a mix. What we've come to understand is that there's no one size fits all in terms of batteries. Even within the vehicle space, some vehicles require higher power batteries, and so they might be chemistries that are or cell designs that are more geared towards that. And others, it's okay if they're heavier as long as they last longer or have a better safety profile. And then you start to get into other applications like grid and home storage versus commercial. So I think what we're going to see going forward is really a mix depending on that application and what technologies are available.
And you mentioned a few minutes ago solid state batteries or silicon batteries. Do you see us really beginning to move toward that in the longer term? It sounds like when I read about industry thinking that the idea is to move away from metals and salts entirely.
Yeah, I think so. There are already batteries out there that are either silicon. So when we talk about silicon, we're talking about the negative anode or the negative electrode or the anode. So I think there already are products out there with batteries that contain silicon, and even a few devices, consumer devices that have batteries that are all silicon anodes. And so I think that transition is coming, and I think it's if we can do that wholesale, it's super exciting as well. I think there's a big open question about solid state, and I will say this is a little confusing, but solid state, some people refer to batteries that have lithium metal anodes as solid state, which is
it's metal.
Because it's metal. But I'll say, so I think that, as I just said, I think there's a lot of promise with lithium metal batteries. Other people say solid state and mean solid state electrolytes. There's a lot of challenges there that I think, if they're solved, could be really interesting. But I think that is going to be, my perspective is it'll be a lot harder to commercialize and bring to full scale, especially for EVs.
Seems like one of the keys to scale here is interchangeability of components. And in the computing industry, we went from widely incompatible components to highly compatible components, and that lowered the cost for everybody. PCs got cheaper, Macs got cheaper, phones got cheaper as we done that. Do we need to think about standardizing interfaces for different types of batteries, or standardizing on specific types of batteries for industries, to your point about specialization?
Yeah. Might be a controversial statement, but I do think that, at least from a size and shape standpoint, the industry as a whole could benefit from standardizing around a few agreed upon formats. And I think there's a ton of benefits there. I mean, it makes manufacturing much more straightforward once you kind of like are able to handle and deal with one size of battery cells. That makes a lot of things easier. You're still able to change a lot of stuff on the inside, like the chemistries and materials, but the outside shape stays the same, and that means a lot of pack designs can stay the same or only need to be slightly tweaked. And then if you start to think about, there's still a big open question on how viable is this second life battery market. EVs reach the end of their life. Are their batteries still useful in other applications? One of the big challenges there is the cost of actually breaking down packs into their individual modules and individual cells in order to better assess remaining lifetime and do something with it. I think standardization of cells and ability to more easily disconnect and disassemble, I think, could have a lot of impact there. The flip side, though, is I think right now we're just in a situation where a lot of vehicle manufacturers are getting very specific about the materials and the cell designs and all the things that go into their pack, because that is sort of the competitive advantage between themselves and the others. And so we haven't really, there have been a couple of efforts, but we haven't really seen that kind of standardization yet.
Well, it'd be great. I have a 7-year-old EV, and it would be good to know that I could swap out cells to keep the battery performing. And I know it's not going to happen with mine, but could it happen with the next generation of EVs? Could we have a highly serviceable battery?
Yeah, could and will are two different questions.
Two different things.
Yeah, could certainly. If we can get everybody into a room that are all the decision makers around this and get them to agree, sure, could for sure. But I don't think that's going to happen in the next 10 years or more.
So let me ask about the next 10 years. What do you think the transportation fuel or energy mix is going to look like in 2035? And what role do you expect Liminal will play in getting us there?
Yeah, I mean, I hope that by 2035, every single vehicle that gets sold around the world will be electric, fully electric. And I hope that that entire mix will be, all the way from your luxury vehicles down to, the most economic vehicle that anyone can afford. Mm-hmm. And as for Liminal, our goal is that, we have by that point played a really catalytic role in enabling that future, right? We talked about a lot of the issues that still existed that need to be solved in terms of battery manufacturing quality and ramp up and reliability and cost. That is a big barrier to getting to that future. And we see ourselves being very catalytic in lowering that barrier and giving the industry kind of the data and insights they need to get there.
If our listeners want to do more research, not just about Liminal, but the battery industry in general, what would you suggest they dig into? Where would you go?
There's so much out there. There's a couple of sources. So periodically, McKinsey and Boston Consulting Group, surprisingly, at least to me at least, put out a lot of really good content on batteries and manufacturing. And then also there's a group called Benchmark Minerals Intelligence, I think, and others like Row Motion that put out really good reports ranging from every week to every quarter. And I think those are all really good sources of information that myself and my team, look to stay updated.
You all have a blog too that people can read? Absolutely.
If you go to liminalinsights.com, we have a blog that we put out our perspectives on a monthly or bi-weekly basis.
Well, hey, I hope people do take the time to go do that, because this has been a really interesting conversation. I want to thank you for talking with us today, Andrew.
Cool. Thanks for having me.
We've been speaking with Liminal founder and CEO, Andrew Hsieh, and you can learn more about Liminal at www.liminalinsights.com. Liminal Insights is all one word, no space, no dash. As Andrew explained, the EV transition is accelerating, but we're still very much at risk of missing national emissions reduction goals because of a shortage of batteries and battery materials such as lithium and cobalt. The mining of these critical minerals, and we need to be careful to avoid justifying further environmental damage caused by mining with words like critical appended to the front of things like minerals. All of this is going to remain a controversial issue. And in addition to innovations in battery architecture and recycling, new mining methods are needed. That's a topic, of course, for another conversation, so stay tuned. But if you're thinking about buying an EV, ask the car dealer some of the questions we discussed. You can send a message that Americans expect environmental responsibility and efficient, affordable batteries. Ask if the car maker has a recycling program. Ask if the battery cells are serviceable individually or require a complete battery replacement if a critical number of cells fail. These questions can help define future design goals for battery makers and car manufacturers. I hope you take a minute to share this podcast or any of the more than 400 others that we produced on sustainability in your ear by writing a review on your favorite podcast platform to help your neighbors find us. You folks are the amplifiers that spread more ideas so we can create a less wasteful world. Tell your friends, family, and coworkers they can find us on Apple Podcasts, Spotify, iHeartRadio, Audible, or any of the other fine purveyors of podcast goodness that they prefer. Thank you, folks, for your support. I'm Mitch Ratcliffe. This is Earth911, and we will be back soon with another innovator interview. In the meantime, please take care of yourself, take care of one another, and let's all take care of this beautiful planet of ours. Have a green day.